Hey everybody, and welcome back to my channel. And what we're going to cover in this video is how we can make our car able to charge in various different situations with different charging infrastructures, potentially different line voltages, with our Thunderstruck MCU or the EVCC. Now, to give you an example here, and what really precipitated this video is, toward the end of the summer, after I got the car kind of working reliably, I decided I want to do a range test. And a lot of times when you do a range test, you'll kind of start out maybe a top line range test where you drive down a flat road and drive back. Well, I didn't want to do that. I know I could probably get about 50 miles of range out of this 20 kilowatt pack in this EV conversion here, but I wanted to really see what it would do in kind of a worst case scenario. So what I did for about over a week, I would just do short little trips, 2 or 3 miles there and back. At one point, I even grabbed my wife and we went to a drive-through about 3 or 4 miles away and sat in there for about 20 minutes and came back. And I did that over and over, little short trips there and back, and I did that for about a week. And I was about 40 miles into my trip, and I decided to do one more trip about 5 miles out and 5 miles in to get that complete 50 miles. When I was about to my destination, about 5 miles away, so 45 miles into this range test, I started noticing the battery sagging big time, and my state of charge gauge wasn't really reflecting the right value. It was saying like 30%, when really it was worse than that. So I knew that I had to stop and pull over and charge immediately because my batteries were sagging. I had a low voltage alarm going off on my state of charge gauge, and it wasn't looking good. I was barely limping. So I get into a parking lot, and all they had in that parking lot was some little outdoor outlets. There were 110 volt outlets and maybe 15 amp outlets. And so I plugged my little portable charger in and I tried to charge, and I noticed that I couldn't. Basically, the charger just kept ramping up and then turning right off again. And I realized what the problem was. So I had to call my son and have him grab my laptop from home and drive out and meet me in this parking lot so that I could plug into the MCU and remove that 220 line voltage setting that I had on my one and only charge profile in the car. Well, I don't want that to ever happen again, where I'm stuck and stranded and I have to rely on my son to bring a laptop to me so I can make a change to my Thunderstruck charging profile. So what this video is going to help us do is avoid that, where we can set up multiple profiles to do a wide range of charging options, and so that we're never left stranded, and we can select them with a switch without needing a laptop. So stay tuned and you just might learn something. Okay, so before we get into how we're going to make a profile selector switch for our charging profiles, let's talk about what these profiles are and why we want to use them. Thunderstruck MCU does support multiple chargers, but talking about multiple chargers is outside of the scope of this particular video, but I want to kind of define the difference between multiple chargers and multiple charge profiles. They're two different things. Obviously, multiple chargers can be set up in the MCU so that you have multiple physical charging pieces of hardware that you can run either one at a time or concurrently. And the way to do that is you actually have to set up these chargers with different CAN bus IDs that are running on the CAN bus network so that they're recognized by the MCU. But it is very common, if you do have multiple chargers, to have multiple charge profiles. And here's a very common example of the charge profiles. As you can see in the EVCC prompt, I have 2 charging profiles, 1 and 2. The second one being the one selected. The first profile says I'm going to charge using one of my chargers, the TSM 2500, which is a 2.5 kilowatt charger. And it's going to be hooked up to a level 2 or 220 line voltage, and it's going to charge a 150 volt pack. This would be a common scenario where I have a small 16 amp level 2 charger like I have at home. If I plug that in, I just want that to enable one of my chargers to come on, because that's all that's required for my little 12 amps of charging. However, if I go to a commercial charger, say at work, and it's capable of 32 amps typically, I want that to turn on both of my chargers. So notice that there's a charger 1 and charger 2 there. They're both the same charger, but they have a different CAN address. And so if I'm using charge profile 2, it's going to expect that I have to be on at least a 22 amp line circuit, and then it'll turn on both chargers and do the full 5 kilowatts of charging rather than just 2.5 kilowatts. Well, you might be asking yourself, well, how does it know the line voltage and the line current in order to do this? Well, what happens is when you plug your J plug into your port, the first thing is the proximity signal is recognized by the MCU, and then it negotiates a pilot signal so that you can get voltage from the charger. Once the charger turns on, it will then tell the MCU what the current line voltage is. So at that point, the MCU will know the voltage. But how does it know the amperage? Well, it knows the amperage by the proximity pin. This is a little guide here. So if I'm plugged into a 20 amp charger here, the proximity pin will show 680 ohms from ground to the MCU, and that's how it kind of knows what that line current is. What that means is I have to be on a charger that has a line voltage of 22 amps or more. So in the case of I plugged into a 32 amp charger, that meets this definition and will allow this to charge. Now what would happen is if I left this charge profile 2 selected and I plug in at my home charger that's only 16 amps. Well, what I've seen before, the way it handles it is it'll start the charger and then after a couple seconds the charger shuts off. So if it doesn't meet the requirements there, it will typically just shut itself off. Okay, so that's multiple charge profiles for multiple chargers. Like I said, configuring multiple chargers is out of the scope of this video. But what's in scope of this video is multiple charge profiles for a single charger. And there are still a bunch of different examples or scenarios where you still need multiple profiles, even if you only have one charger. One example is direct plug versus J17 charging combinations. The MCU supports the notion of being able to directly plug in, meaning just an extension cord plugged into your car. You don't actually have a J1772 charger. In that case, you still need to set up a new profile that says the plug type is direct plug, not J1772. So therefore, it knows not to negotiate a pilot signal. Now, read the instructions on the MCU manual. You may still need to ground out the proximity pin or do something with that. But the direct plug needs to be configured in a charge profile so that if you do plug into some direct 110 inlet that you set up on your car with an extension cord outside of an apartment complex, for example, that this profile will allow it to happen. Versus you might still have a J1772 plug on your car as well, and everywhere else you go, like public charging stations or whatever, you would use that profile that knows to negotiate the pilot signal and do the J1772 charging. Another very common scenario is you want to be able to support both level 1 and level 2 charge combinations. And that's kind of the scenario that I'm going to talk about a little bit later because that's what I'm going to implement in my car. Another common scenario might be time of use charging. The MCU supports a delay of charge. So for example, maybe you get home from work every night at 6 p.m. and you plug in at your garage and then you walk inside your house. But you don't actually want the charging to start because you want to wait till off-peak hours for it to start charging. You may want to set up a charge profile that does that wait time before it starts charging versus another profile where it doesn't have that option and you just want to immediately start charging. And then another scenario might be you have access to a CCS or DC charging framework, and the Thunderstruck MCU supports that 0 EV CCS type charging platform. See that plug in that picture, notice that it has a J1772 plug, and then below that it has another large 2-pin plug. What that has is both a J1772 AC charging, level 1, level 2 or whatever, plus a direct fast DC charging in the plug below it. So some common profile scenarios you might want to do is have one profile that just does the direct DC fast charging, but just a bulk charge to only 80% state of charge. I'm not exactly sure how to implement that, but I've seen people do that, and I think what they do is they can use the maximum voltage or the termination time to simulate about an 80% state of charge on your battery. And that may be a scenario where you want to set it up because you know you're only going to be able to do a CCS DC charging someplace for under an hour. So you select that profile. But maybe you get home and you have access to CCS DC charging apparatus and you want to do a full DC charge up to 100% with top balancing option as well. Or at home you don't have that and you only have a J1772 charger, so you might want to set up a profile for that. Or any other combination of the above options as well. So now you can see even with a single charger, you still need multiple charge profiles potentially to deal with different hardware wherever you're out and about driving around. Okay, so like I mentioned, my proposed charging profile is going to be this. I currently just have the one profile, and it looks very similar to what you see right now in that charge profile 1. But what I want to do is add a second profile. So let me explain my current situation here. I own 2 portable 16 amp chargers that can operate both level 2 or level 1. And at level 2, they're 3 kilowatts. At level 1, they're only 1500 watts. But one of the things I mentioned in a previous video was without specifying that line V requirement, so notice on my profile 1, I have that 220 specified. Without that specified, Thunderstruck has a weird heuristic built into it, such that if it sees under a 20 amp line C, which is, again, I mentioned through the proximity pin, which my 16 amp would qualify as under that, it just assumes to be a level 1 or 110 volt charger, and it only gives me up to 1500 watts of charging, which is half of what my charger is capable of. Well, the hack there is to say, nope, for this profile, I'm always going to be at a level 2 by putting that line V of 220 in there. And that way it will pull the maximum out of that charger, which is 3 kilowatts. And if you do the math, 220 at 16 amps still gives you about 3.5 kilowatts of charging. So it does work. So this number 1 profile works for my home charger, my level 2 16 amp charger. And if I go anywhere like a commercial grade 32 amp and above charger, it'll also work for that as well. And it also can do the top balancing. Now, I want to create a new charge profile that you can see here, number 2. It's still going to use a J plug, but notice now I don't have line voltage or line current requirements. So my little 16 amp portable charger, I'm going to keep in my car at all times. So I don't need that direct plug option. But that, again, is a 16 amp charger, which without that line V requirement, Thunderstruck is going to assume it to be a level 1. And I also notice I have a max charging current of 13 amps. That will ensure that it's always going to be doing up to a 1500 watt charge no matter what. And this is the profile I'll choose maybe 1% of the time if I'm out and about, like in the situation I described before. I'm in a parking lot kind of stuck and I need to plug into a little 110 outlet there. I will be able to do that and it won't shut down my charger. It will allow it to charge with that profile too. So this is what we're going to implement. Now I am going to take you through implementing a 4-position selector switch for your charge profile selection that allows you to select all 4 profiles. Even though I'm only implementing 2, I'm still going to provide a 4 selection switch so that I can add new profiles later that I can still select. Okay, so now that we understand the what and the why of what we're doing with charge profiles, now we're going to start talking about how we're going to do that. Well, it all starts with this input 5, notice, in the Thunderstruck MCU. So I'm going to add new wire into that input 5. But what does that need to do in order to do the charge selection? Well, we have this P-select input function, and in order to use our charge profile, when charging, the P-select input function must be mapped to an input. And in our case, we're going to map this P-select input function in our MCU to that input 5, and I'll show you that later. So when charging, the P-select is used to select the profile. The MCU measures the resistance to ground at this input and determines 4 possible selections for our 4 profiles: INF, 20K, 5K, and 0. And the formula is as such. If the resistance to ground that's in that input wire is above 30K or it's just open, it's considered INF or infinity. If the resistance in that wire to ground is less than 30K but greater than or equal to 10K, it's considered the 20K range. If it's less than 10K but greater than 2K, it's in the 5K range. And if it's under 2K and anything down to 0, it's considered that 0 range. So the resistance that our switch is going to provide to that input 5 is going to define one of these 4 ranges, and that's going to be mapped to one of our 4 profiles. So let's start by determining what type of hardware we need for a 4 selection switch and how we're going to make it simulate these resistance values to that input wire. Okay, so I brought you inside my desk because what we're going to do first is get our hardware solution done, and I want to do that inside in the warmth before I have to go out in the cold garage and work out there. So I figured let's do that here. Now the first thing I bought was this 4-position selector switch here. So if you look at the switch, it's commonly something you would find on a fan or a heater, and it's got 4 positions: off, 1, 2, 3. You can hear by the clicking. So really, we might say 3 position, but off is considered a position. So off, 1, 2, 3, right? And on these terminals here, there's 4 terminals around the outside of this square casing. And basically what you have here is one has an L on it. I don't know why it's really L, because it's really a common. So that's the common, and then you have 1, 2, and 3. So the way this works is you put your wire into the common, and for us that's going to be a ground wire, because the input we're going to do to our P-select function is going to be a ground or a resistance to ground type of thing. So we're going to run the ground wire into the L. So for off, it'll just be open to ground, which is our INF. For 1, I'm going to wire that, just put a wire directly out of the terminal 1 to our P-select input, which will be 0. So that's our INF, or completely open to ground, and that's closed to ground, or our 0. So those are our 2 or P-select positions. The other 2 P-select positions are the 5K and the 20K, as I mentioned before. So what I'm going to do is on the 2 here, which will be position 3, on this 2 terminal, I'll have a 5.6 kilo ohm resistor wired in, and then on the 4, I'll have a 20 kilo ohm resistor on that. Now, what I want to just talk about real quick is I've got this space heater that I have in my bathroom here. I'll put a link in the Amazon to this heater switch here, but notice that that's exactly what's built into this space heater. This 4-position switch, which my knob broke on it, but it still works, so I didn't want to take it off of this heater. And you have off, fan only, 1 and 2. So this has a 4-position switch exactly like this one inside of it. And the reason I want to bring this up is because I've recently have built myself a habit of anytime something like this breaks in my house, it could be a little space heater, it could be a microwave oven, a blender, a piece of computer equipment, no matter what, I will always harvest it before I throw it in the trash. So for this one particularly, I would harvest this switch, so I would have something like this that I don't have to buy from Amazon. I would probably harvest maybe this knob and this rheostat here, but then I would also harvest, and in my previous EV build, I actually harvested these ceramic elements out of a space heater and put them into the heater box and made an electric heater out of it for that EV. Each one of these elements is 750 watts. So if you wanted to develop, like, say, a 3,000 watt heater for your car, you can take 4 of these and make something like that. So always harvest components before you throw something away. With my microwaves, I have fixed multiple times by taking a magnetron or an ultracapacitor or something like that out of a previous microwave where it broke for some other reason, and used that in a new microwave and was able to fix that and get a few more years out of it. So always harvest your things before you throw them away, so you don't have to buy more stuff. Okay, so here is the switch wired up, and what I've done here is I have taken this wire, a long black wire here that you can't see, and it's hooked up on one side of my ohm meter here, and that will be hooked to my ground. So that's going into that L terminal, like I mentioned, which is the common. Then all the other terminals have a wire coming off of them, and they're going into this wire nut right here. So you can see each of these wires come off the other 3 terminals on there. And then I've got this thinner wire coming off of that wire nut, and that's going into my red multimeter wire. So the idea here is you have ground coming in, and then you have our 3 positions all going into the same wire nut and all feeding this little thin wire that's going to go to my input for my P-select. So this is considered our output wire, and the big ground wire here coming in is considered our input wire. Now what I've done here is on this number 1 terminal here, this is just a straight wire. That's all this is. It's a straight wire going into the wire nut. But these 2 terminals, this is not a straight wire here. This is a shrink wrap 5.6 k ohm resistor coming off of 2, and then a shrink wrap 22 k ohm resistor coming off of 3. So the way this is going to work, and what I'm going to simulate here on my meter here, is at our position, I'll call it position 0 or position 1, however you want to do that. That's the off, right? And as you can see, our meter is OL or INF or whatever. It's open. There is no continuity here. Then when I click to 1, notice that that's going to go to full continuous or 0 ohms. So we've got our INF 0, and now we'll go to 2, and then notice that we have 5.5 kilo ohms. You can't see that, but that's the K ohms. So we have our over 5K resistor in there. Then we go to 3, and then notice it changes to 21.88 kilo ohms. So we got our 22 kilo ohms, which is our 20K ohm range. So there are all 4 of our ranges: INF, 0, 5K, 22K, or 20K. Okay, so now we're in the car and we're back by our battery box here and my high voltage junction box here. And as you can see, I installed the switch right there. And here is what it looks like. Okay, don't make fun of me too much. I know it looks pretty folksy, pretty amateur hour here, but I'll find a smaller knob and some better labels later. Now, if you think about where you want to place it, this is easy option for me because I'm not going to use it very much, and my MCU is mounted right under the lid of this box, so I've got easy access for that input 5 wire. But if you wanted to mount something like this that you're going to use often, maybe in your charge port, just make sure you buy a waterproof multi-select switch if you're going to mount it there, or you can put it on your dashboard or anywhere else. The only thing you'll have to worry about is getting that one wire routed into that input 5 on your MCU. Here's the inside of the wiring, and as you can see, this is all that junk in the switch, and I've got that little thin wire coming off of here. That's our output wire with our resistance value, and that's going into this input 5 right here. And of course, the larger black wire is going down here, around into here, and into this terminal distribution block, which is all of my 12-volt chassis grounds, right? So yeah, that's why I said you can mount it anywhere in your car that you need. All you have to deal with was that one input wire because you can get a chassis ground from anywhere in the car. And that chassis ground terminal block right there is also what's feeding the main ground input into the MCU, which is connector A, pin 1. So that's how it knows about the ground as well. Okay, so we have it all physically wired now. So our next thing is to go into our terminal and actually configure it in the programming. If you're confused about all the stuff that I'm about to do, I'll put a video above my head to my initial Thunderstruck MCU video, and in that video I'll show all the wiring, how it wires up, what you need to install on your laptop in order to connect to it, and then how you can connect to it and issue commands as well as program some stuff. So that's a prerequisite video to this one because I'm going to assume you already know all that stuff. Okay, so now we are in PuTTY and we've connected to the MCU. And the first thing I'm going to do is test whether or not my input 5 is actually working. So I'm going to go to the sys prompt here and I'm going to type in SH. So right now it says input 5 is INF, and because I have it on that first position, that makes sense. That should be INF. Okay, so now I'm going to go to position 2 and we'll issue a show and we'll see that that in fact is input 5 is 0R. So that is what I expected. It's the one that's completely continuous. Now we'll go to position 3 and issue another show. And now it's saying 5.6K, perfect. So there's our 5K range. Then we'll go to 4, issue another show, and now our input 5 is the 21K. So perfect. The input 5 is recognizing all of our expected resistance values. Now what we're going to do is we're going to issue a command to map input 5 to the pselect function. So the way you do that is you'll say set in5 space pselect. So now anything coming in from input 5, those 4 resistance values, will now be mapped to our P-select function. Next, we're going to go to the EVCC prompt. I just typed in EVCC, enter, and then we'll hit a show on that one, or a show config on that. Okay, so the show config right now shows our single profile that we have, and what it's showing here now is these new settings here called PMAP. Notice that now that we have our P-select configured, it's mapped every single value of the PMAP to our one and only charge profile. And the reason for this is that if I start flipping the switch and I only have one profile, it's to make sure that that one profile is always selected, right? So it won't actually do anything until we add our second profile. So now we're going to add a second profile, and the way we do that is we simply type in edit profile on our EVCC prompt, and we're going to call it 2. So what this means is it puts me into the editing of that profile. So we'll do a show config again, and you'll see that now we actually have the second profile created, and it's starred, so it's currently the one that's being used, because even though we have none of the mapping functions on it, every function I do now to set something will be to do it to this second profile. So if, for example, that TSM 2500 isn't my charger. My charger is the Elcon. So I'll say set charger Elcon. Now if I do a show config, you'll see that my charger type for my second profile is also the same Elcon. And I'm just now realizing that I'm using the word charger to refer to both the onboard charger on the car and the charging station that's outside of the car. So I apologize for that. Just hopefully you can use your context to figure out what I'm talking about. Okay, so these are still not the values that I want. So I'm going to go ahead and set a lot of the other values to match my first profile. The only thing I'm not going to include on this first profile is the line V of 220, because I want it to assume it's a level 1 charger every time, so I can charge anywhere where I'm at. So what we're going to do is set the max voltage, and that's what we want our charging voltage to be at 182. And then we're going to set the max current, which is max C, and we only want to do that for about 13 amps instead of 23. And then we can also just set max. We'll set max term T to, let's just say 480 minutes for now. Okay, so let's reset my terminal, and then we'll show the config, and we'll see if we have everything we need. Okay, that looks good enough for now. Okay, so there's our second profile, but notice that my PMAP settings are still all for the first profile. So what I want to do is I want all of them to resolve to the first profile, my default profile, and only the 0 to actually resolve and make that select my second profile. So let's see how we're going to do that. Okay, so in the manual it says that the way you're going to do that is to say set PMAP, and then the PMAP that you want, which in our case is just called 0. You're literally going to type in whatever the value is there, like 20K, 5K, or 0. And then space 2. So that'll set the 0 profile to 2. Let's see if it did it. Good. Okay, so now we notice that all 3 of our PMAP settings are resolving to our default profile 1, and only the 0, which in our case is our second selector switch, is going now to 2. What I'm going to do is I'm going to set my selector back to the first position, or INF, and then I'm going to plug in, and what I should see if I do a trace charge is that if I plug my charger into a 220 volt outlet, it should still charge at the full 3 kilowatts, and then I'll know that it's using my profile 1 for the charging. Then I'm going to take the same charger and plug it into a 110 outlet, maybe even a 15 amp 110 outlet, just like I had when I was stranded out in that parking lot. And I'm going to plug that in, and I'm going to confirm that, yes, it will not charge with this with this one. In other words, the charger turns off because it doesn't match the profile 1. But then we're going to turn it to profile 2, and if it does start charging, we know that we are in fact on profile 2 for our charging. So let's see how that's going to work. All right, well now with my trace charge on, my selector switch on 1, and my 220 plugged into this charger, let's go ahead and plug it into the car and see what happens. Okay, well my little 12 volt charger's having a little trouble with the fan this cold. The charger's ramping up, and as you can see, the wattage is ramped up and it's over 3 kilowatts. So that's good. We've got our 220, our charge profile 1 seems to be working just as it did before. All right, I'm gonna go ahead and plug this, and this time I'm gonna plug my little portable onboard charging station into a 110 outlet, and we'll see if that works as well. Okay, so when I plugged it into the 110 outlet, what you see on the trace charge is it tried for a few seconds here, and it just simply couldn't provide any amperage or any charging into the system. And notice we ended up with a charge state of terminated due to EVSE timeout. Therefore, we have confirmed that what we expected, our profile 1 will not allow us to charge at 110 because of that line requirement, but it will allow us to charge at the 220. Well, now let's pretend that we're out and about. And so I'm going to leave it set up to be plugged into a little 110 outlet here. And I'm going to switch to the charge profile 2. And then we're going to try plugging in again and see what happens. We should see the charger should not only stay on. Well, so far it looks good. On profile 2 with this 110 outlet, we are charging. And let's see where the wattage caps off. Maybe it's only 1200, I have no idea. Yeah, so we are charging. It's not acting like before. It is satisfied with the charging profile. It's only charging at about 6 amps or about 1100 watts. So good. If we were out in the wild like I was before, all I would have had to do is flip it to charge profile 2 and plug into any 110 outlet, and I would have gotten at least 1100 watts of charging going on. Well, great. It looks like we're a success. So as long as I keep this little portable charger in my car at all times, I never have to worry now. So whether I'm plugged in at 220 or 110, I know I have an option to complete my charge. Well, that's about it for this video. I hope you learned something. And if you did, leave a like or a comment on it. And if you like content like this, whether it's EV conversion, car restoration, mechanical work, or DIY home content, this is the channel for you. So go ahead and subscribe to that. And until the next video, I'll talk to you later.